next up, we have a really interesting talk titled Bridging the Gap Between NLP and Talent Teams Using Topic Modeling. And that'll be delivered by two of our extremely talented colleagues here at hackajob, Caspar, Hughes, and Chris Howlin.
Hello, can you hear me? Coming through clear?
Yeah, all good.
Excellent. So yeah, this is Decoding Talent, bridging the gap between NLP and talent teams using topic modeling. And mainly this is going to focus on topic modeling itself and how you can get information from text. As Phil said, I'm Caspar, lead data scientist at hackajob, and this is Chris, senior data scientist. We are 2 of 3 data scientists at hackajob and mainly focusing on how we match candidates to jobs. And today we're going to give you something with this talk, we hope. We're going to talk through what topic modeling is, talk through some of the modern methods, how we've been using it. We're going to mention how it works on our particular data set, so how this could work for recruiters, how it means particularly on candidate CVs. And what we really want to do is we want to show the power of this tool for all text. So if you've got Python, and you'll be able to do it yourself. So we really want out of this for you to be thinking about how does text work, and to give you an opportunity to do this on your data if you're savvy enough to write about 5 lines in Python. So let's get into it. What is topic modeling? Topic modeling, I'm going to start with something potentially quite basic. So, but data science is getting knowledge and insight from data. And I'm going to split it into 2 broad themes, because I think that's useful for us. There's some of data science, which is about predicting the world. And this is typically when you want an action to occur, you want to set a price, you want to display something on a screen, maybe an ad. You want to predict what's going to happen, you want to optimize for that. And that's typically autonomous. That's without humans. And then there's the explaining side, which is where you're trying to, with a human in the loop, you're trying to explain how things work. And in particular, topic modeling is about the organization and explanation of large amounts of text. If you have large amounts of text, how do you automatically organize, understand, summarize, and explain text documents? So that's what we're looking at today. And organizing, when you want to organize something, you need to have ways to describe it. And the better you describe them, the better you can organize them. And good descriptions focus on what is important information about the subject. You've got this car here. We'll probably explain that it is a blue car with a roof rack, some chains on its tires, maybe the license plate's important. But you would ignore the details that maybe aren't important to your use case. Like you wouldn't talk about every single crack, every single smudge, because they're not useful for organizing and explaining. So at an individual level, we're good at extracting those important features of the car to group them. And with text, we do that ourselves. So if we want to get useful information from text, we want to organize text, get descriptions from text. We do, I'm sure we're all familiar with reading. We read the text here, the recruiter might sit and read it, and then in their brain, they kind of pull out these themes of numbers of years experience, they worked at Netflix, maybe Java, cloud experience. And that's good for a deep assessment and a few CVs at a time. But it does start to kind of creak and struggle when you look at huge amounts of things. So it takes time. If you want to read 100 CVs, that takes a very long time. It also relies on your pre-existing knowledge. To know the terms within the text base, to understand what the different roles are, you have to have been taught those to pick them out, or you're going to have to be looking up lots of different words to find out how they connect to each other. So it relies on all this pre-existing knowledge. And eventually you reach your limit. You've got a capacity, you can probably only keep 5, 10, 15, maybe candidates in your mind. So to get a picture of how to organize things as a whole, is difficult when you start to hit the tens of thousands, 100,000 different texts or documents or candidate CVs in our case. So with the blue car, it's very easy, but quickly organizing all the cars on the right, that's very hard. And so we need tools to be able to help understand this. And this is where individuals can answer, is this a good fitting candidate? But they struggle to answer, broader questions about 10,000 people. So what are the roles and what are all the roles on the platform? What are the responsibilities that I don't know? And how have these mix of responsibilities changed? These grander, describing the full set of things is very difficult to do on an individual basis. And so we can do this with topic modeling. Topic modeling can take tens of thousands of CVs, 100,000 CVs. We can apply some data science magic, and we can get a set of useful descriptions that explain what the raw text that was in there, how it looks like, and how we might better organize and understand what groups are in that text. And what we're going to show you is definitely not just contained to candidate CVs. The first time I used these techniques, it was on PubMed data. So we took a bunch of abstracts from PubMed based on dementia, and it broke down all the topics for me without having any pre-existing knowledge. So you can apply this to your Slack channels if you wanted to see what you were talking about, tweets or threads if that's a new thing. We're at Sky, so maybe like film captions, company policy documents, export your WhatsApps if you wanted to see what your mates talk about. But any text documents can be categorized, organized, understood, and explained through topic modeling. So bear that in mind. We are going to go through CVs examples, but this can definitely be applied to other domains. So yeah, there are lots of methods of topic modeling. Traditional one relies on keywords. We still use keywords quite a lot at hackajob. They're very useful and very easily understood, but they have their shortcomings. Keywords don't have context, so plucking single words out, sometimes the context changes, sometimes the meaning changes. They don't group multiple keywords together very well, so you don't really get this sense of the overall topic that comes through. There are some conventional methods, such as LDA, which is latent dirichlet allocation, for anybody who wants to look it up. But they too work on individual words. And there's been a not so recent development, recent as in, I think transformer models came out in maybe 2018, but they're quite popular now, are these large language models. And these allow for a huge amount of context to be held and more in-depth semantic meaning to be extracted from large amounts of text. And we're going to talk about that method, and it's been shown to outperform the conventional methods by far, things like BERT, things like OpenAI. And the ways you can use these is that you could either make 100,000 calls to ChatGPT asking what the topics are, getting descriptions, but that is going to be painfully expensive, incredibly slow, and probably inconsistent, to be honest. We're going to show you a way that you can use those models via the embeddings, use an incredible tool called BERT Topic, which Chris is going to talk about, and how you can combine that with OpenAI to get from zero knowledge, knowing absolutely nothing about the text, meaningful clusters and ways to organize the text that you have that help you understand what is happening and what the different types of conversations, different types of topics actually occur in that text from zero knowledge. It builds upon the basis of these large language models to separate the different types of things that are being talked about and yeah, be able to describe that to humans in a meaningful and kind of segmented way. So I'm going to hand over to Chris. Chris is going to talk about how we actually do this at hackajob, And yeah, BERT topic, the tool.
Yeah, so I'm going to talk about how we've actually taken some of these ideas and applied it on the data that we have, and you built a kind of actually surprisingly straightforward tool that summarizes our data in a really surprisingly powerful and meaningful way. So just before we get stuck in, Caspar already mentioned the BERT topic library. We just want to give a big shout out to this and Martin Grutensdorst, who has made the package. This is a really fantastic package which brings together a lot of concepts in topic modeling and presents them in a nice modular framework, which we'll dig into in a little bit, and has got fantastic documentation and examples, and also has really good integrations with Hugging Face, OpenAI, to just give you so much capability in just one library. And this is all something that's come out in the past year or so. So the paper associated to this came out in 2022. This is, we're all aware of the big trends in generative AI and large language models, and the stuff we're going to be talking about here is only recently possible at this level of kind of ease in the last couple of years. So what does BERT topic do? It provides a way to summarize unstructured data into meaningful clusters of documents, which are also called topics. But a lot of topic modeling talks about text, but actually BERT topic also provides interfaces for topic modeling images. So you could give a load of images and then say, oh, these are the ones which are about blue cars, and these are the ones which are about dogs, for example. So yes, very, very modular, and yeah, it's got kind of pretty seamless integrations with Hugging Face and OpenAI. And on the right here is just an example of how when you take the topics and map them onto a 2D space, showing how they cluster together. And this is something we'll see a bit more in some of the later slides. So how does it work? The general approach is that when you've got something like text, you need to transform it into vectors, also called embeddings. So there's been a lot of study of this over the years. The most recent kind of revolution is the transformer architecture, which was like 2017, 2018, which allowed you to generate like highly contextual word embeddings, and there's a wrapper around this, which BERT topic uses, called sentence transformers. It uses an algorithm called SBERT, which then stitches these words together into a single embedding for your piece of text. So that means that you can take a paragraph or a sentence and get a numerical representation out of it. Obviously, with the models that we work with, it's all about numbers, and you need to have a format that the models can work with. Typically, these vectors are pretty large. So the defaults with BERT topic is the mini LM v6 transformer model, which I think the output dimensions is about 350, 360 dimensions, which is huge, massive space. So in order to make the problem a bit more tractable, there's a dimensionality reduction step, which uses a technique, an algorithm called UMAP, which is a kind of very non-linear way of taking the structure in high dimensions and maintaining that locality of structure into a low dimensional space. And I think by default, it will map you down to 5 dimensions, which is then input into a clustering model, which is really the core of where the topics come from. So the technique inside is called HDB scan, which is a hierarchical density-based modeling approach. And this also is a way of clustering that works kind of non-linearly and does the clustering by density rather than some other approaches like k-means, where you have to pre-specify the number of clusters, and it's not flexible to the shapes inside the data space. So the output of the clustering step is then you've taken your documents, you've got the numerical format, you've kind of grouped them together into similar documents. What do you do next? Well, that's not very useful on its own. So the last step, and I think this is actually the topic of the original BERT topic paper, was the TDF IDF representation, which is that calculating what are the most representative words inside this topic. And this is really a kind of modified form of the TF IDF, which is a way of picking up most sort of specific words inside a group of text. And the combination of all that together gives you some word representations for the documents that you have grouped by topic. And I think really there's a lot of pieces here which have been around for varying amounts of time, and where the magic comes in is actually the grouping them all together in this way. It gives you a really powerful transformation. So just to kind of give an example of how flexible this is, I think one of the standout points of that topic is it's got really nice architecture in the way it structures things. You have a lot of flexibility in terms of how you calculate your embeddings. So by default, we will use sentence transformers, but as we will see in our presentation, you can also plug in the OpenAI backends to generate embeddings for you. You can apply whatever clustering dimensionality reduction techniques you like. Some of these, the HDB scan and UMAP are quite intensive. You can swap out like PCARK means, which are maybe more tractable if you've got huge amounts of data. And then things like the tokenizers. If you have like Chinese Mandarin text, you can use the JBER tokenizer and actually get the topics for you in Mandarin, right? This is the flexibility there means you're not just limited to sort of Latin scripts. So let's see what we've done. So we kind of had two versions of this. The first approach we had was, okay, let's take the default BERT topic model using the SBERT sentence transformer embeddings. The challenge with this is that the models that we're working with by default only had taken 256 tokens as a context. So a context when you're talking about a transformer model is how much text really, or the tokens that you generate from text and you pass in at one time. So it's kind of like a word count limit. The tokens are actually kind of sub bits of words that are broken up, which are really the atomic units that the model works with. But the challenge is here that when you're working with a candidate's work experience, that can be very long, right? It could be hundreds and hundreds of words, and you've then got to find a way to break it down enough to put it into to embed that in your transformer model. So the first step we took was, okay, let's just take basically all the sentences, tokenize that representation by sentences, and pass it in through BERT topic, and fit a topic model there. And what you get out of this is a set of topic probabilities for each sentence that you passed in. And that is kind of works. The problem is that you then have 15, 20 sets of probabilities for each document you're working with, right? So actually, that's not what you're interested in. You're actually interested in describing the work experience itself. So then you've got to figure out, okay, how do I aggregate this? So what we did was like taking the maximum of each topic probability, fitting another topic model on top of that, seeing how that summarized the work experiences. But actually, the performance of that is not great. And we've got some examples of what the output of this looks like. So in the one of the many great visualizations that you get with the BERT topic package is it will show you for each topic, so that's each kind of group of documents, what are the representative words for these documents right here. So we've got like this topic 0 where it's got a kind of a weird set of things. It's got this responsibilities thing, which the responsibilities word, which just seems very high. You have then lots of small frequency words. Another topic with responsibilities seems kind of random. Okay, topic 2, it seems to have something more meaningful there. It seems to be something to be cybersecurity related. Topic 3, we've got a bunch of dates. That's kind of weird. And basically what we're seeing here is because we break apart the the work summaries by sentence, we get a lot of spurious artifacts which are not really meaningful. So in the case of the responsibilities, what we see is that the standard formatting on the hackajob platform is that someone will put responsibilities, list of bullet points. When we're breaking that into sentence, we're seeing lots of sentences. Almost every work experience has that topic in there. We also see if someone's been working at a company for a long time, or maybe they've been doing consulting work, they'll have one job, but inside there they'll say, 2016 to 2019 did this, 2019 to 2021 did this. And actually they've got some kind of substructure inside here as well. So that kind of translates these artifacts where we see, where we've somehow pulled out this sort of not very useful structure from the document, from the work experiences, and brought them out there. And the thinking is, okay, well, maybe we can like change some of the parameters of the model. Maybe it's the problem with the way that we're aggregating it. Maybe if we took the average of the vectors instead of the max, would that work? And then we thought, wait a minute, we've been playing around with OpenAI and OpenAI embeddings in other areas. Let's give this a go. So I think I jumped over. So then we thought, wait a minute, OpenAI, one of the products that they provide is that you can actually embed text and mass using the latest model with the AW2, which actually has a context window of 8,000 tokens, which is way bigger than whatever we need to represent any candidate work experience. And it's just an API call. You say, take this document, give me the 8,191 dimension vector back. And then that means that we can just take each work experience and it gets embedded with the OpenAI backends as part of BERT topic. And then you just have one representation coming out per work experience. And that's massively simplifies the problem. And the benefit as well is that because these embeddings are essentially a summary of that entire document, you end up actually removing a lot of these artifacts that we're seeing, where you've kind of picked up random sentences that appear in lots of documents, and actually ends up, when you dig into it some more, with some higher quality representations, and fewer higher quality topics as well. So here we're showing 7, but there's actually about 200 topics that come out of this versus over 600 that were coming up with the sentence by sentence approach. Even 200 is kind of more than probably what's reasonable here, but it's a much easier problem to manage, like merging and aggregating those topics from that set than from the set where you've got sort of 650 or so topics. We can still see that there is this kind of topic 0 here, where, which is for people typically in consulting roles where they do have lots of work experiences, but actually overall it's a lot better. And also, as a benefit of this, we also get a nice hierarchy of topics. So you can see, hopefully you don't have to squint too hard. So you've got this like green hierarchy, sub-hierarchy, where it's related to like Microsoft administration. We've got a red one where it's sort of DevOps related. The cyan one is like penetration testing, going up to cybersecurity. Just clicked on, there's an embedded video which seems to have taken me out of the slideshow, but we can see goes from penetration testing to cybersecurity all the way up to kind of cyber and IT support and administration. So it kind of shows that you actually get a lot of really nice structure off the back of this. I'm just trying to.
Right, one moment.
Oh yeah, it's just one of those.
This.
There we go.
Yeah.
And then we come to the sort of OpenAI part 2, right? So that by default, the outputs you get from BERT topic will be a topic summary. So here you've got a topic which is related to kind of AWS DevOps type work. You have a set of keywords and some representative documents that you can query. So this is an example, DevOps engineer, of a candidate work experience that sits inside this topic. It's kind of useful and helps you make sense about, is this topic, meaningful? Are the documents coherent? But actually, if you're trying to make it relatable for an end user, it's kind of how does someone who's not really thinking about it in terms of the model process this? So what we did is we actually can take these outputs and ask ChatGPT to summarize them. So the output of taking these summary keywords and the representative docs actually says, okay, this document is about DevOps engineering, and these are the typical responsibilities that you see in here. You know, wow, that's amazing. You know, this is exactly where ChatGPT shines. And this is done using, just to show you, these are the prompts that we use to do this, right? So you have a system prompt which says, this is the task that you need to do. I want to have a topic summary, 3 words long, typical responsibilities, list 5 responsibilities. You pass in the user prompt, which is like the specific of the task, and then that generates this out for you. We've found that, you know, using the GPT-4 does a better job of this immediately, but actually with some tweaking of the prompts and spending a little bit more time on the prompt work, you can actually get almost just as good outputs using 3.5 versus 4 at about 10% of the cost. Right? So actually, with a little bit of tweaking, you can save a lot of money on this. And I think, so maybe I've got this on the later slide, this process of summarizing the documents was about $1. And combined with the earlier step of generating the AI embeddings, which was about $2.60, we've got a system in place where we can generate topics for all of the hackajob documents for about $3.50. And here, once we've got these summaries from ChatGPT, then we can just start plotting these the frequency of these documents across the candidates. And what's really amazing here is that without any kind of structured data, apart from the documents themselves, we're able to extract the frequency of the different candidate profiles and the different work experiences across the platform with like 0 structured work. And this is it's incredible, really. The last bit that we have here is then we've been working on the candidate space. What if we took a job description? In this case, it's a hackajob senior data scientist job description that we had up before. If you take this text and say to Bert Topic, find me the most similar topics of this text, what it sends out is, okay, I can see that there's data scientist type responsibilities in here, and also machine learning engineer responsibilities. So what we could do then is start surfacing some of this information to a recruiter who often has some experience in the space that they're working in, but not as in depth as people who are working in their day-to-day. And when they're matching with these candidates on the platform, they can understand about where these people sit in that space. So it provides more context. It sort of takes information in the job description and then helps contextualize it in the context of the candidates on the platform. So yeah, just to summarize to that, what we've seen here is that you can actually generate high quality topic summaries with extremely low domain expertise. Right? You need to have your documents, embed them using OpenAI, pass them through Bert Topic, get ChatGPT to summarize them on the back end, and you can see the results are just very impressive without really needing to know too much about how the techniques work, and even too much about the domain. And tools such as OpenAI have greatly reduced the barriers for this. Just the ability to take full documents, not have to break them up or tokenize them, just pass it in, get out meaningful results, really reduces the technical barriers. And it says here the total end-to-end run, so summarize of this is about $3.50. And what I think was really remarkable is that a lot of the ability to do this only came out in the last year. So Bert Topic 2022, the latest super cheap Ada V2 embeddings came out this year. So this is really kind of on the forefront of what you can do easily with these tools.
Nice. And so yeah, I think that was a great summary, and I just want to remind that we can have these zero knowledge descriptions and organizations of text now because of the new tools, and you can do this. This is CVs. You can, if you get the Bert Topic package, you can take any of your text data, as long as it kind of conforms to what the LLM has seen. So you'll be able to do this as well. Small bit of Python knowledge, and yeah.
Yeah, I think you could probably do something in 5 to 10 lines of Python. You could do something very similar, which is incredible, really.
Yeah. So yeah. Do we have any?
Amazing. Absolutely amazing. Yeah.
And the fact that I think the real thing to impress is that it is the zero knowledge is quite incredible. No labeling, all that information is contained in the large language model that you then are drawing out through BERT topic. So yeah, if you've got a chat app, everybody's building chat apps and LLMs. If you want to look at what types of things people say in your prompts, you can start to cluster them, start to understand what's being talked about at scale, at huge scale. So yeah, I think it's really cool. Any questions?
Thank you very much, fellas. So we haven't had any questions in through the Q&A function just yet. So if anyone does have any questions out there, please do get them in. We're more than happy to go through anything you'd like to ask. But I did have a few questions that kind of came to mind as you were going through the presentation anyway. So, you've touched on the fact that this is moving super quickly, right? There's new tools, there's new processes, there's new models coming out all the time. I guess what challenges are you still wrestling with? Like where are you hoping to see perhaps a new tool come out in the next 6-12 months? Like what's the blocker at the moment, or what could be better based on the work that we're doing so far?
Yeah, I think the biggest challenge with the new tools, so using these new embeddings, I think is excellent for us. It's kind of like having a large context is a real big, it kind of really opens up what you can do with text. Ada is 8,000 tokens, but there are, I think there are ones that are coming out that have nearly unlimited context windows. It's got weird, strange implications, but and how well they attend to certain parts of the text. But I think the real challenge with some of these tools is actually on the product side. Like, how do we take the kind of generative element and give something useful that kind of a user, maybe be a recruiter or a candidate on the platform, something that they can actually use that isn't, that helps them with their flow, helps them with their work, that isn't, dare I say it, like gimmicky. So I think integrating that into a platform and dealing with the uncertainty, because these generative algorithms typically, you can't really plan and account for bugs in the same way that you can with other tools. So accounting for edge cases when, there's a potentially infinite number of things it might pop out and say is, I think, one of the biggest challenges with the kind of generative element. But I think in terms of the embedding element, it's just a boon for people like us who have been working with just a lot smaller contexts. And I think we're starting to see that it really does help with And
I just say as well, with the topic modeling approach that we've been doing, where you are kind of calculating the topics in your document, that gives you a kind of a fixed structure that then you can work off of, right? You're not processing this on the fly. You've actually got meaningful descriptions that then you can review and join on. In some cases, what we do see that there's a bit of redundancy, like Java engineer and Java developer might be separate topics. We can actually merge them together, make sure it's still meaningful. So this way of kind of using this cool stuff, but getting it down into a savable structure that we can review, actually kind of manages some of that risk as well.
Yeah, and it gives you a point of reference, so you can then check again you can rerun it in a couple of months, and you can say what responsibilities are not being classified by our topic model, and then you can start to look at what's new, what's been occurring recently. And I think for us, it's very interesting, and the usefulness is probably lower for us because we have very well labeled data. We collect, we have talented curation teams who speak to candidates, actually write down what they do. So our data is very well labeled, but I think if anybody's on the call that has very poorly labeled data, doesn't have the time to label, I think this will be even more powerful because you won't have a basis to kind of build on. So the real zero knowledge, and I love that it's standing on the power of these LLMs that have taken all the kind of context of whether or not legally or not, they've taken all the context of the internet, and we can benefit from that.
Yeah, for sure. Yeah, we don't need to worry about that side of it. As you say, we can apply these fantastic tools to lots of use cases within our businesses. We have had a few questions come in now. So first one, so how are you addressing, or just your general thoughts around latency issues with large language models, for it to be used in production in a meaningful way, leading to good user experience? So I guess, have we had any issues, or have you had any thoughts around kind of latency and like the lag?
So it depends on the problem. If you're doing like a large call, there is going to be huge mass latency, but these are the types of techniques that actually help you skip those calls. Like if you were making a ChatGPT, if you're making a call to tell you say for instance what the topic was every time, that is very expensive, because you're going to have to make a call every time that happens. If you instead take and build a topic model, if your problem is such that you've got a fixed thing, like you want to find the topic of these documents and you want to find a job title, you can build a topic model instead, and processing through a topic model is incredibly fast. Like getting embeddings from OpenAI takes a second for about 100 large text. So getting embeddings and passing them through a topic model is super speedy. Can be GPU accelerated as well for UMAP. That is incredibly fast, much faster than making calls. So if you start using ChatGPT to summarize documents, to find topics, you can actually replace it with these processes. So you can do the topics on the fly, and you also get a stability. You get a list of topics and descriptions that you can check and you can vet beforehand, and not like be totally at the whim of
yeah. I mean, ChatGPT, etc., is being fine-tuned all the time. Like, you know, what comes back one day to the next, or even across similar candidates in different docs, is, you know, how do you know whether it's stable or not?
Yeah.
You kind of don't.
Yeah. I think so it depends on if your use case is something that changes all the time and there's no stable output type, then you probably are at the whim. But if you are using it for classification or directing text into certain buckets, then you can replace that middle bit with a topic model and get most of the way there, and probably have some, you know, if it's not very close to any topics and if it looks like it's guessing, then you can send it to ChatGPT. So you can try to use a topic model, which is very quick to implement, and very quick, low latency on a call. And then if it fails, you can send it to the slower ChatGPT call. But yeah, I think it depends. Is there a fixed set of things that you can extract from topic models? If so, I recommend using them because they're a lot quicker.
Thank you very much for the advice. We have one more question. I think we've got time for one more question, essentially, for the end of this session. So this user or this attendee, sorry, works for an enterprise company, and there's reluctance to use external LLMs and other models with concerns around security, data protection. So how did the two of you go about kind of getting buy-in from internal stakeholders within the business to utilize these sorts of tools?
Yeah, so that's why we're particularly using the work experience extracted summary, which is just the responsibilities. Why we haven't sent any candidate CV text, just taking the responsibilities, because it doesn't contain people's names and stuff like that. So yeah, eventually I think, you know, it would be nice to use candidate CV text. I think OpenAI have come out and they've said explicitly, I think it was after the big Samsung issue last year, where there was some data leakage, that they do delete data anyway after 30 days, I think, and they don't retrain on it. But we don't send names or CV data to them. We do send our job descriptions, but we've taken, you know, to do some summaries, but they usually don't contain those either. So yeah, at the moment we don't send that sensitive data, and I think it's a difficult one. I mean, we have lots of service providers. Lots of companies have service providers for data, and I think it's about checking, yeah, doing the due diligence on those companies, and the same as you would like a data warehouse provider. And yeah, I think we treat it such as that, and I think any LLM company that retrains on data that you send, I just don't think you should be sending any data to. I think that's kind of like a clear red line. And yeah, eventually I think there's new models coming out all the time, and especially Llama 2, like it's probably very expensive to train yourself, but if you work for an enterprise company, I'm sure there's going to be, like, I think Databricks like make it quite easy to train your own in-house one. So if you can start showing value on test data and you can get those conversations, then you might be able to get the tens of thousands of pounds to train.
Llama 2, you can fit it on one single GPU now. It has to it's like a $5,000 GPU, but in an enterprise, actually the capability you get from that could be a very compelling business case.
And it's 26 gigabytes of RAM, GPU RAM it needs. So yeah, that's comfortably within kind of cloud infrastructure. So if those conversations are difficult and you want to, start sending things that might have sensitive data risk, then I recommend showing examples with some test data and arguing for testing some in-house hosted kind of within your safe net LLM.
Excellent. Thank you very much, fellas. Really, really good advice there. And thank you so much for taking the time to deliver in such an insightful and interesting presentation. I'm sure everyone out there listening and looking has, the cogs whirring. I'm sure plenty for everyone to take away. So yeah, thank you so much for joining us.